Okay, this is lesson 1, and we're going to talk about parallel lines cut by transversals. When parallel lines are cut by a transversal, corresponding angles are equal. First of all, parallel lines are two lines that will never cross. And the way you know you're dealing with parallel lines, if you have a picture, is that they each will have a little arrow on there like this. Cut by a transversal just means a line that crosses the two parallel lines. That line is called a transversal. You can see that 4 angles are created right where the 2 lines are crossed by the transversal. And when it says corresponding angles are equal, it means that if this is angle 1, there's another angle just like it down here in the same position with relationship to the transversal and the parallel line. So on top, that angle 1 is above the parallel line and to the left of the transversal. The one on the bottom is also above the parallel line and to the left of the transversal. So those two angles correspond to each other and they are the same measure. They are equal in measure. If you are looking at the vertical angle that goes with angle 1, of course, those two are equal because vertical angles are equal, and the same thing happens down at the bottom. Those are also equal. If we look at that angle right there, that blue one, it is above the parallel line and to the right of the transversal. If we look down at the bottom, there's another one just like it, above the parallel line and to the right of the transversal. Those two angles correspond, and so they have the same measure. We also know that the vertical angles associated with those have the same measure as well. And so this is what it looks like when you have parallel lines cut by a transversal. You basically just have two different angles. There are 8 angles total, and really there are only 2 different measures, but corresponding angles are equal. Okay, so here's an example. We have 2 parallel lines cut by a transversal. We're given some information about the angles. We know that this angle is 60 degrees. This angle is below the parallel line and to the left of the transversal. Its corresponding angle is right there. So we know that angle is also 60 degrees. So since we know that angle is 60 degrees, we know that the vertical angle to that is also 60 degrees. That tells me that C is 60 degrees. We know that 60 down here and A form a straight line. They are supplementary. So I know that 60 plus A is 180. Subtract 60 on both sides. A is 120 degrees. So I know A is 120. Then I can look, A is below the parallel line and to the right of the transversal. B is also below the parallel line and to the right of the transversal. So B is also 120. It's the same. Okay, now we're going to look at something that happens when 3 or more parallel lines are cut by 2 transversals. And this is not about angles, right? This is about segment length. So this is a different kind of situation here. We're not thinking about the angles now. We're thinking about lengths of segments that are cut off when this happens. So take a look at that left transversal. You've got a segment here. We'll call it A. We'll say the length of it is A. And then that segment that's cut is, we'll call it B, and we'll say that its length is B. On that right transversal, we'll say this little segment here is C, and the one at the bottom is D. What this is saying about the segments being proportional is just that A over B is equal to C over D. So whenever 3 or more parallel lines are cut by 2 transversals, you get proportional segments. All right. One way to find a missing segment would be to use this proportion. A over B is equal to C over D. Another way that you can express this idea is that there is a scale factor which relates the segments on the left to the segments on the right, meaning there is a number, we'll call it F for factor, that you could multiply by AF, it would equal C, and BF would equal D. So there is a number, one number, that if you multiply a segment on the left by that number, you will get the segment on the right. These two things mean the same thing. This way of doing the problems, finding the missing parts, is slightly quicker because you don't have to find the scale factor. You can just set up the proportion and figure out the answer. So let's just look at an example and we'll do it both ways. All right, so we have three parallel lines cut by two transversals. We have a segment here that is 2. We have a 5. We have another segment over here on the right transversal that's 6, and the bottom one is x. So from what we just learned, 2 over 5 is equal to 6 over x. All right, whenever you have a proportion, you know that the cross products are equal. So 2 times x is equal to 5 times 6. So 2x is equal to 30. So x is 15. Right? So the other way that you could think about this problem is to say there's some number I can multiply by 2 to get 6, right? So 2 times some number, I'll call it f, is equal to 6. Well, that number obviously is 3. If I multiply 5 by that number, I'll get x. So that's 15. So there's the scale factor way of doing it, and there's the proportion way of doing it. They both give you the same answer.